Lesson 1.3, Part 1, Names of Polynomials and Operations with Polynomials. So first we're going to do a warm-up just like we were working on from yesterday. Rationalize the denominator. So remember that you can't have fraction exponents or radicals in the denominator. So go ahead and pause the video and then you can unpause it to see if you got it right. Alright, so first break it apart and write the cubed root of 8 over the cubed root of x squared. What is the cubed root of 8? That would be 2. And then finally we have that over the cubed root of x squared. But I'm missing something from that denominator to make it a perfect just x. So if I make it the cubed root of x squared times the cubed root of x, that is going to be the cubed root of x squared times x to the first, which ends up being the cubed root of x to the third, or just x. So whatever I multiply to the denominator, I must also multiply to the numerator. So then your final answer, let's see, 2 times the cubed root of x. So if I combine those would be x to the third. The cubed root of x to the third would just be x. Okay, so there would be your final answer. Some of you guys have been liking to do this one with changing your exponents to fractions instead of leaving them as radicals. So here's an alternative method to solving this problem. When you get it down to the cubed root of x squared, we could rewrite that x to the 2/3 power and then think, what am I missing to make it x to the first? So we're missing x to the 1/3 power. 2x to the 1/3 over x to the first, or 2 times the cubed root of x over x. So either method will get you the same answer. All right, just to review one term, like 4 or 6xy or 10x squared would be a monomial. Okay, two terms would be a binomial. Usually we look at the two terms, a lot of times we're looking at it when we're looking at the factors. So x plus 5, but it could be something more complicated like 4x squared y plus 7. Trinomial would have 3 terms. The most common ones are when we're factoring again. X squared minus 6x plus 5. And then polynomial has many terms. So it could be anything more than 3. We don't have a special name for. So we'll just call it a polynomial. Okay, some textbooks go more specific and say polynomial with 4 terms or something like that. But we're just going to go with polynomial. Okay, for ax to the k, a is a coefficient. So the number out in front is called the coefficient. And then x is the base and k is the exponent. The degree of a polynomial is the highest exponent on the variable. So 3x to the 8th plus 5x is a binomial with degree 8. Leading coefficient is 3. Okay, so find the one that has the highest exponent. That's going to be also the one that goes with the leading coefficient, because you want to put you want to have your function in or expression in standard form. Okay, reminder here how to add or subtract polynomials. You can combine like terms. So for this example, if we have our x cubed and our x cubed, we can combine those. That would be like a 1x cubed plus 1x cubed. That would be a 2x cubed. Okay. Go ahead and pause the video, see if you can finish up number 1. All right, so be careful with the negatives. Negative 6x squared plus 5x squared would be negative 1x squared, or just negative x squared. And then minus 5x, and then plus 4. You could rewrite that and just drop off that 1. Would be a little bit simpler, but both would be right. For subtraction, you need to be careful with this minus sign. So you need to do x cubed minus x cubed, negative 6x squared minus 5x squared. So one thing I like to do on a problem like this is just change this to like plus and then distribute my -1 through. You don't have to do this step, but sometimes it makes it easier. Then you don't have to think about how to subtract a negative. So I'm just going to rewrite this first part out and then multiply all these times -1. So now if I combine my like terms, our x cubes end up canceling out. Our x squareds, negative and a negative would be -11x squared. Our x's would end up being 2x plus 7x is 9x. And then our 4 just stays the same. Okay, to multiply polynomials, we can use the distributive property. So a couple things. This would be difference of squares, this first one. This is perfect square trinomial. And this one's another perfect square trinomial. So you don't need to memorize these. We can just FOIL it out to figure it out. So if we want to expand this, we're going to go FOIL first. Then we've got outside. Then we've got inside. And then finally last. Okay, so go ahead and try that first one, and then we'll look at the second one. So you should have 6x squared minus 7x minus 5. For the second one, it's basically the same thing. We just have too many terms to call it FOIL. So you're going to do your first, then we've got to do our middle, and then we've got to do our last there, or outside, I guess. So it's like you're taking x squared times everything, and then we're going to go through and take -3 times everything. -3 times x cubed, -3 times 2, and -3 times 1. Don't forget the negative on that 3. All right, so if we do that, x squared times x cubed. So I'm going to write that out real quick. So you got to think, would we add or multiply those exponents? Is it x to the 5th or x to the 6th? We'll come back to that in a minute here. Then we go x squared times 2x plus 2x to the 3rd. Then we're going to go x squared times 1, so plus 1x squared. Now we're going back to the -3. -3x cubed minus -3 times 2 minus 6x, and -3 times 1 minus 3. So going back to that x squared times x cubed, you want to add those exponents. So x to the 5th. Okay, there's no x to the 4th, so we're going to skip the x to the 4th term. X cubed, there's 2 of those, so we have a 2, and we have -3, so it'd be minus 1x cubed. All right, there's only 1x squared, so just leave that one how it is. And then there's only one x and one number, so we'll just write those how they are. So x to the 5th minus x cubed plus x squared minus 6x minus 3. So if you wanted to, you could drop that 1. There we go. All right, more practice with multiplying here. So again, you can use that FOIL, or you can just think about taking 1 times everything from the other set and then take square root of x times everything. So if we do the first, 1 times 2 would just be 2. Then we're going to go to outside. 1 times -3 times square root of x. So minus 3 times square root of x. Then inside, plus 2 times square root of x. And then last. So square root of x times negative 3 square root of x minus 3 square root of x square root of x. Okay, so if we simplify this, 2 stays there. So we have a minus 3 times square root of x plus 2 times square root of x. So it's like, that's how many square root of x's you have. Okay, so you can add like terms since they're the same radical, same index. So we have a negative 3 and a positive 2. Okay, so we can go negative 1 square root of x. And then this last one, minus 3 square root of x times square root of x. Square root of x squared, which is just going to be x. Okay, so then we can simplify and get 2 minus the square root of x minus 3x. Okay, for number 6, be careful with this one. We can't just like distribute that squared. We have to think of 2 of these. If you just take it 9x squared plus 25, that will not get you the right answer. Okay, so now you can FOIL first, outside, inside, and last. So go ahead and pause the video. Check if you got it right. 9x squared plus 30x plus 25. All right, similar to how we did that previous problem, since it's to the 3rd power, we need 3 of these. Because there's a subtraction sign, or if there was an addition sign, we can't just distribute that power. We can only do that if everything's being multiplied or divided. Okay, so what you want to do is just take 2 at a time. So start foiling with 2 of them, and then we'll save that 3rd one for later. So if I go first, so then I look at my outside and my inside, they end up being the same thing, minus 2x squared, which would be minus 4x squared. And then last, minus 2 times minus 2, negative 2 times negative 2 is positive 4. Okay, so now we're going to drop down that factor that we haven't used yet, and then do this again here. So we're going to take x squared times everything, and then we want to take negative 2 times everything. So if I take x squared times each of those, x squared times x to the 4th, remember you want to add those exponents. So it'd be x to the 6th minus, and then 4x squared times x squared, 4x to the 4th, and then 4 times x squared plus 4x squared. Then we're going to do it with the second one. Now, one little trick to just make simplifying a little quicker is just to drop these down right below. So negative 2 times x to the 4th would be negative 2x to the 4th. Just kind of drop it right below the like terms. Negative 2 times negative 4x squared would be plus 8x squared. And negative 2 times 4 would be minus 8. Just a way to just add like terms quick. You've got everything lined up. But you wouldn't have to do it this way. You could do it left to right too. All right, last one. Why don't you guys pause the video and see if you can try number 8. Okay, this was the difference of squares example. Notice that you have the same exact factors, 1 plus and 1 minus. So what's going to happen is the outside and the inside term are just going to end up canceling out. So you're left with 4x squared minus y. Okay? So your assignment is page 33 and 34 in the pre-calculus textbook, and then numbers 16 through 50 even.